right? We have to get the answer for this one. First, I have to represent the sign. Sign is here minus in this question. So therefore, I have to write 1101. Then I have to represent this number 3, 0, 0, 1, 1, right? One block. First block is complete. Then the second one, I have to write this number 7, 0, 1, 1, 1. Then the 2, 0, 0, 1, 0. Then here, this one, I have to write 0, 0, 0, 1 in this block. Then what I'm going to do, the rest of these 4 bits in this block, then I have to put the unsigned value 1, 1, right? Now it's okay. It represents 1 from here, 2, 3, sorry, the 7 here, from 3 here, and the minus sign is from here, right? This is very easy. Fact BCD is the easiest one. Right, then the next one is ASCII. This one. The problem, the representing text string such as hello world in a computer, how you can represent, right? Because computer knows only the 001s. That means the digits. The computer doesn't know these text, hello, HOWRO, right? Those letters computer doesn't know. It knows only digital signals represented in zeros and ones. Then here the codes and characters. Each character is coded as a byte. In here in ASCII representation or the ASCII standard, each character is coded as a byte. Most common coding system is ASCII. ASCII stands for American National Standard Code for Information Interchange, defined in ANSI documents, right? This is the document. The definition is there in that document. Then the ASCII features 7-bit code. 8-bit is unused or used for the parity bit. Then for the each representation, it uses 8 bits, but 7-bit is used for the representing the value or the text. 8-bit is unused. 2 to power 7 equals 128 codes. 2 general types of codes. 95 are graphic codes displayable on console. 33 are control codes, control features of the console or communication channels. For example, when you press delete key, when you press enter key, when you press control key, how to identify, right? So 33 different types of codes are reserved for these controls. 95 are used for the graphical things representation. For example, characters, numbers, what are the things we can display on the console? That means on the screen. අපේ screen එකේ පෙන්වන්න පුළුවන් type කරාම ඒ දේවල් වලට 95ක් තියෙනවා වෙන් කරලා 33ක් වෙන් කරලා තියෙනවා අපිට type කරා කියලා එක පේන්නේ නැහැ screen එකේ. නමුත් control වැඩ වලට ඕන කරනවා. උදාහරණයක් delete key එක, enter key එක, tab එක ඒවා press කරොත් වෙන්න ඕන දේවල්, right? ඒ key එක press කරාම ඒ key එක press කරා කියලා identify කරගන්න code එකක් තියෙනවා, right? There is a code to identify whether that key has been pressed. So that's code, those codes are used for the control things. We call them control codes. See, this is the ASCII chart, right? In here, in this chart, this axis, x axis, right? When you see this one, x axis or the horizontal bar, right? These bits are most significant bit. And from here, from top to bottom, right? These are used for the least significant bit in a code. අපි හිතුව මොකක් හරි කෝඩ් එකක් ප්‍රෙස් කරා කියලා ඉවර වෙලා මේ තියෙන අපි A අකුර ප්‍රෙස් කරොත් එහෙම A අකුරේ සිග්නල් එක කම්පියුටර් එකකට යන්නේ 7 bit code එක. Actually 8 bits are there, but we use only 7 bits, right? 1 bit is reserved for the parity bit, right? ඒ හින්දා ඔයගලන්ට මතකයි, right? හැම එකක්ම හැම character එකක්ම number එකක්ම එහෙම නැත්නම් අපි මොකක් හරි key එකක් press කරොත් ඒක display වෙන්නේ නැති key එකක් වුණත් උදාහරණ delete key එකක් වගේ වුණත් ඒක කම්පියුටර් එකට සිග්නල් එක යන්නේ ඒ key එක press කරා කියලා මෙන්න මේ code එකකින්, right? digital code එකකින්. එතකොට මේ digital code එක හැදිලා තියෙන්නේ කොහොමද ළමයි? මේ chart එක බැලුවොත් ඔයගලන්ට identify කරගන්න පුළුවන්. මෙතන තියෙන්නේ, right? මේ මුලින්ම තියෙන තුන ඇවිල්ලා most significant bit. Can you remember the most significant bit? Most significant bits are the leftmost bits. වම් පැත්ත කෙලවරට එනවා තමයි හැමතිස්සෙම, right? If you think of the most significant bit, එක bit එකක් ගැන හිතුවා නම් මොකද්ද? ඒ කියන්නේ leftmost bit එක තමයි. Right? Least significant bit එකක් ගැන හිතුවා නම් ඒ කියන්නේ මොකද්ද? Rightmost bit. දකුණු පැත්ත කෙලවරේ තියෙන එක. But in here, in this line, it shows the most significant 3 bits, and this one shows the least significant 4 bits. Then when you how to get the code for a particular character, මොකක් හරි character එකකට code එකක් ගත්තොත් මේකෙන් ඔයගලන්ට පුළුවන් මෙන්න මේ විදිහට හදා ගන්න. අපි හිතමු A එකට, if you want to get the code for the A, right, from this chart you can write 110 as the most significant 3 bits, here 110. Then from here you can get the least significant bits, 0001, 0001. අපි ගත්තොත් එහෙම ළමයි B කියන එක, let's say not B, right? We'll take this one, C. How can I write? First I have to write the bits represented in here, right? In this line. That means C equals 110. Then I have to get the bits from the here, 0011. So if we consider this as x-axis, right? Let's say we consider this as y-axis, right? First 3 bits are taken from this x-axis. Then the other 4 bits are taken from the y-axis. Then you can make the code, right? අපි ගත්තොත් එම r කියන එක, if you want to write represent the R's ASCII code, then how can you do that one, right? From this chart you can get first 111 as the most significant bits, 3 bits, 111. Then you have to find the corresponding least 4 significant bits here, 0010, 0010. Then you can write the R. Then if you want to, let's say you want to write the capital H here, this one, how can you write that one, capital H? First you have to find the value from this x-axis. Here it is under the 100. Then you have to find the value from the y-axis, from here, least 4 significant bits. 1, 2, 3, 4 here, 1, 0, 0, 0. Now you can, right? Write the code, 7-bit code, 7-bit ASCII code for the capital H. Right. Now, please make a harima lazy. ඕගොල්ලෝ මට ඉක්මනට type කරන්න ASCII code එක capital V. What is the ASCII code for the capital V? Right, how can you find the ASCII code for the V? So that's easy. First, the V is here, capital V I asked, right? First, you have to get the 3 most significant bits. This from this line, 1, 0, 1. From this line, you got 1, 0, 1. Then you have to find the least significant 4 bits from here, 0, 1, 1, 0. 0, 1, 1, 0. That's the answer. Right, good. I have received answers from Yasara Pereira, right? All are correct. Good. Then we will move forward, right? So these are the 95 graphic codes, right? That means when you type this one from this one, right, it will be shown on the console or the screen. Then the others are reserved for the control key, right? Please tell me, give me the ASCII code for the delete key. This one, not this here, this one. Type the ASCII code for the delete key, this one here. Right, what's the code? First, you have to get from here, this axis, x-axis, 1, 1, 1. Then you have to get it the least significant 4 bits from here, 1, 1, 1, 1. Right, මේක තමයි එහෙනම් delete key එකේ ASCII code එක. Right, for the last exercise from here, please tell me what is the ASCII code for the escape. When you press the escape button, what code will go to the computer processor under the ASCII standard? Escape එක press කරොත් ළම. Okay, for the escape key, you have to find the most significant bits from here, 0, 0, 1. Then here, least significant 4 bits, 1, 0, 1, 1. Right, that's the ASCII code for the escape key. Right here, the 33 control codes you can see from here, 95 graphic codes and 33 control codes. Then alphabetic codes, that means for the characters, right? When you type the characters, right? These are the, from here you can find the codes for alphabetic characters. And numeric codes are from here. For the numbers, codes for the numbers you can get from here. And punctuations, right? You can get the ASCII code from here for the punctuations. Right. Then you have to write the ASCII. Right. I am going to give you a name, right? Now you have to write the ASCII code for that particular name. Right, for this one. Command. When you type this one, this name, so what are the codes going into the computer under the ASCII standard? You have to keep remember, right? For each and every letter, what code is there. Okay, then we will get the code for each and every letter one by one. Let's take first for the K. I'm going to find for this one K 100, and when you get the least significant 1011. That's for the K. For the A, it's a simple A, right? I have written here simple A and capital K. Simple A, this is the code, right? 11000001. Then for the M, simple M. It's not capital M. This one, M. 110. And from this line, you have to get the other part, 1101. Then again for the A, the same one, you don't need to go to refer to the chart again, because we have already written the code for the A. The L, simple L for this one, simple L, 110, 110. Then the other part you can get from here, 1100. Right. So that's the answer. Okay, student. Then we'll move to the next one. If you write this kind of a one, hello world, right? Example, H is represented in this code, E is represented in this code, like that. And this one, right, comma is represented in here in this code. These are some common control codes. Delete, null, right? So the terminology, learn the names of the special symbols. For this one, we call brackets. For these symbols, we call braces. For this one, we call parentheses. Then this one at sign, right? And ampersand and tilde. For this wavy mark, right? What this says, escape sequences extend the capability of ASCII code set for controlling terminals and formatting output, right? The escape code is ESC1B16, right? Normally you students, right? You know, we can write them, these codes can be represented in this hexadecimal numbers also, right? But you learned how to represent the code in binary numbers. It's a binary representation under the ASCII, right? But we can use also these hexadecimal numbers. But in the examination, I don't think that the things from this hexadecimal representation will not come. Right, okay, then the next one is EBCDIC, right? Extended BCD, interchange code. Pronouns EBCDIC. So 8-bit code, it's 8-bit code developed by IBM and rarely used today, IBM mainframes only. So you don't need to learn about this one. Then the Unicode is the next one. Unicode is 16-bit standard, right? You know, nowadays Unicodes are normally used when you want to represent the other language letters from the other language, right? For example, singular letters, right? If you want to represent the singular letters in computers, right? We use the Unicode. Actually, you don't need to learn much under this Unicode, right? So those are the most important part in this lesson. Now you know, right, several things. For example, you know how to write binary coded decimal BCD, and then you know the format of packed BCD and so on decimal, right? So on decimal and packed decimal BCD, you know how to write them, and you know the ASCII representation, right? Because I have seen several questions from this ASCII area. Right, okay, then you can have a break.